Today, we will learn. Let us first discuss what a system actually means. A system is an arrangement in which all the units work together according to systematic or schematic instructions. For example, a clock. It is a time displaying system, and if one of its parts fails, the system stops working. Now, what is an embedded system? An embedded system can be thought of a computer hardware having software embedded in it. These are designed for a particular task to be completed in a stipulated time. For example, a mobile phone. It is a communication device which performs the task of voice transfer. It transfers the voice of one person to another person. So it has the microprocessor embedded in it to perform this task. Similarly, television, washing machine, microwave ovens are embedded systems designed to perform specific tasks and have a certain type of microprocessor. Like micro ovens are used for cooking or heating. So it has a microprocessor embedded which helps to perform that particular task only. They are different from general purpose systems like a PC which has different processors and can perform a lot of functions. Embedded systems. Now we see the embedded systems have three basic components: the hardware, software, and the RTOS. RTOS is the real-time operating system. Here, let me tell you that a few small-scale embedded systems do not have RTOS. Further, we see the characteristics of embedded systems. First, it is single-functioned. As seen earlier, it can perform a single or specific task. Tightly constrained, which means it also has its own limitations or boundations. Microprocessor based memory, like the other devices, it also has some memory. Connected, it means it has peripherals which basically are ports for making connections. Hardware and software systems. Now this is the basic structure of embedded system. The sensor which takes the input and converts it to electrical signal which can be read by the device. AD converter is the analog to digital converter which converts the analog signal to the digital signal. The processor processes the data and stores it in the memory. DA converter is the converter which converts digital signal to analog signal, and finally the actuator compares the output given with the actual output. Next, we come to the processor, which is the heart, or we say the core of the embedded system. It is the basic unit which takes input and processes it to give an output. There are two essential units of a processor, the CPU and the EU. The CPU is the control unit, or it is also known as the fetching unit. It fetches instructions from the memory, and the EU is the execution unit which implements instructions from the memory. The EU has circuits which implement instructions pertaining to data transfer and data conversion. Now, for an embedded system designed, we must know microprocessor and microcontrollers. Microprocessor is a central processing unit on a single silicon-based integrated chip. It has no RAM, ROM, input-output units, timers, and other peripherals on the chip. It has the heart of the computer system, which is the processor, and it is used for general purpose application systems. But in case of microcontrollers, it is the byproduct of the development of microprocessor with a CPU. It also has a CPU with a RAM, ROM, and other peripherals. It has the brain of the computer, and it is used for application specific systems only. Let us have a quick look at the positioning of the microprocessor and the microcontroller in the CPU. Next is the ALU, which is the arithmetic and logic unit, which has a part of the execution unit. It executes instructions by interruption or jumping to other instructions. Here it is important to know that the instructions are processed in the same order in which they are fetched from the memory. Thus, to conclude, it is necessary to emphasize that the embedded system performs specific tasks, and the design engineers can reduce its size and cost without affecting the reliability and performance of the system.